Assalamualaikum and a very good day, Dr. Hasima. I am Siti Rabiyah. We'll start presenting our assignment titled Risk Analysis of Public Transportation System in Klang Valley, assessing the risk affecting the effectiveness of accessibility, affordability, environmental impact, and service liability. Okay, let's begin with the introduction. Public transportation is a cornerstone of sustainability urban development. It connects people to jobs, education, healthcare, and commerce while reducing congestion and environmental harm. The World Bank 2021 notes that inclusive accessibility transport system boosts economic productivity and social inclusiveness. Klang Valley, covering Kuala Lumpur, Petaling Jaya, Shah Alam, Klang, Kajang, Subang Jaya, Selayang, and Ampang, is Malaysia's largest and most economical important metropolitan region. Rapid urbanization here has placed enormous pressure on transportation infrastructure. The Vibe 2024 reported that commuters lose more than 500 hours every year just sitting in traffic congestion. To address this, the government has invested heavily in rail and bus networks, the MRT, LRT, monorail, KTM commuter, and rapid KL buses. But despite this investment, several serious problems remain. In May 2021, BBC News reported that two LRT trains collided near KLCC station on the Kelana Jaya lane, injuring more than 200 passengers, one of the most serious rail incidents in Malaysia history. In 2022, the Stars also reported a major disruption on the same line that left thousands of commuters stranded. These incidents to point out four key problems area that frame our entire study: accessibility, overcrowding, inconsistent schedules, and limitation suburban coverage, affordability, rising fuels and maintenance costs pushing up fares, environmental, greenhouse gas emission and urban air pollution, and service reliability, breakdown, signal failure, and disruption from flash floods. Because most past studies look at these four areas separately, our research aims to assess all of them together within a single integrated risk framework, especially for Klang Valley. As public transportation demand grows in Klang Valley, several challenges continue to affect its effectiveness: service disruption, overcrowding, affordability concern, and environmental risk. While previous research has studied accessibility, affordability, environmental sustainability, and service quality separately, very few studies have combined this dimension with systematic risk assessment tools such as risk metric analysis and qualitative risk assessment. This gap led us to define 6 research objectives, each paired with corresponding research questions shown here side by side. First, to evaluate the accessibility of bus and retail and rail transportation system in Klang Valley, asking how accessible are the system. Second, to assess the affordability of public transportation service for users, asking are the fare affordable. Third, to analyze the environmental impact of this system, asking what are the environmental impact. Fourth, to evaluate service reliability, asking how reliable are the services. Fifth, to identify and assess measure risk using the risk metric and QRA methods, asking what are the major risks affecting effectiveness. And sixth, to propose mitigation strategies, asking what strategies can reduce this risk. This is our literature review. Brohi et al. 2018 found that Malaysia's smart city development depend heavily on efficient, environmentally sustainable public transport, which directly reduce congestion and air pollution. Hassan et al. 2025, studying Johor Bahru and Penang, shows that strong transit network improves social inclusion by connecting people to jobs, healthcare, and education. Efficient transport also raises workforce productivity by cutting travel time. Accessibility is about how easily people can reach and use public transport. Hassan et al. 2035 again found that route connectivity and coverage are the strongest predictors of user satisfaction, while Mavoa et al. 2029 showed walking distance to stations significantly affect ridership. On the challenges side, Chan et al. 2020 found that fragmented operator and poor coordination make transfers difficult in Malaysia. On the solution side, transit-oriented development or TOD and real-time tracking apps like Unibus have been shown to meaningfully improve perceived accessibility by reducing uncertainty. Abdul Majid et al. 2022 emphasized that rising fuels and maintenance costs threaten the long-term affordability of fares, making government subsidies essential. Importantly, Hamzah et al. 2022 found that affordability alone isn't enough. Service quality must come with it, or commuters won't switch from private vehicles. Yusuf et al. 2021 framed public transport as social return investment rather than a purely profit-driven service, which is why government support it through subsidies and financing tools like Sukuk. Transportation is among the largest sources of greenhouse emission globally. The World Resources Institute 2023 confirms that public transport produces significantly less carbon dioxide per passenger compared to private vehicles. Yusof et al. 2021 points to Klang Valley-owns MRT Kajang line as a concrete example expected to cut both congestion and emission, while Soleimani 2022 recommend fleet electrification and low-carbon fuels as further strategies. Deanna and Deanna 2021 found that punctuality and consistency are strongly linked to passenger satisfaction and loyalty. On the flip side, breakdowns, signaling failures, and infrastructure malfunctions erode commuter confidence and discourage repeat use, which connects directly back to the LRT collision and disruption mentioned earlier. This is where our methodology takes shape. Even 2021 defined risk assessment as a structured way to identify, evaluate, and prioritize uncertainties. We'll be using two main tools: risk metric analysis, which prioritizes risk by likelihood multiplied by impact severity, and poison distribution, which models the frequency of count-based events like delay or service incidents. And this brings us to our research gap, which is really the foundation of our entire study. Previous research examined accessibility, affordability, environmental impact, and reliability, but almost always separately. No existing studies has integrated all four dimensions with systematic risk assessment methods, specifically risk metric analysis and poison distribution in context of lung rally. Our study is designed to bridge exactly that gap, delivering what we believe is the first integrated framework for Klang Valley public transportation system. This setup, the methodology we'll walk through in the next chapter. With that, I thank you.
Hi everyone, my name is Farra binti Norais, metric number 834944. So moving on to chapter 4, this chapter explains the methodology used to achieve the research objectives. This study adopts a mixed method approach which combines qualitative and quantitative methods. The qualitative approach was used to identify transportation-related risks through literature review, documented transportation incidents, and brainstorming among the researchers. The quantitative approach was then used to evaluate these risks by collecting survey responses from public transportation users in Klang Valley. Overall, the research process consists of 5 stages: risk identification, data collection, data analysis, risk prioritization, and finally proposing mitigation strategies. This study used a mixed method research design. For the qualitative part, transportation risks were identified from previous studies, documented transportation incidents, and discussions among the researchers. This helped us determine the potential risk related to accessibility, affordability, environmental impact, and service reliability. For the quantitative part, we conducted a cross-sectional survey using Google Forms. This means the data were collected once at a single point in time to understand respondents' experiences and perceptions of public transportation in Klang Valley. The target population for this study consisted of public transportation users in the Klang Valley. This includes commuters who regularly use services such as the LRT, MRT, KTM, commuter monorail, and public buses. To collect the data, we use convenience sampling, where respondents were selected based on their availability and willingness to participate. The questionnaire was distributed online through WhatsApp and other social media platforms. In total, approximately 60 respondents participate in this study, which is considered sufficient for this research. For the data collection, we use a structured questionnaire developed using Google Forms. The questionnaire consisted of close-ended questions measured using a 5-point Likert scale, ranging from strongly disagree to strongly agree. The questionnaire was divided into 5 sections. Section A collected respondents' demographic information. Sections B, C, D, and E focused on accessibility, affordability, environmental impact, and service reliability, respectively. This structure ensured that all research objectives were covered in the survey. After the data were collected, the responses were analyzed using Microsoft Excel. 3 analysis techniques were applied in this study. First, descriptive statistics were used to summarize the survey responses, including frequencies, percentages, and mean scores. Next, risk matrix analysis was conducted to determine the severity and priority of each identified transportation risk. Finally, the Poisson distribution analysis were used to estimate the probability of transportation-related incidents occurring within a specific period. Risk matrix analysis were used to prioritize the identified transportation risk. Each risk was evaluated using 2 criteria, namely likelihood and impact. The overall risk score was calculated by multiplying the likelihood score by the impact score. Based on the final score, each risk was classified into one of 5 categories, which are very low, low, moderate, high, or extreme risk. This analysis helped identify which transportation issues require immediate attention and mitigation. In addition to the risk matrix, this study also applied Poisson distribution analysis. This statistical method is suitable for analyzing count data and estimating the probability of events occurring within a specific period. In this study, it was used to estimate the likelihood of transportation-related incidents such as service delays, service disruptions, overcrowding, and operational failures. The analysis was based on the average number of incidents reported by the survey respondents. The results provided additional support for evaluating transportation risk. On the left side of this slide, you can see that the formula we use for Poisson distribution for this research. This slide summarizes the overall research framework. The study began with risk identification through literature review, documented transportation incidents, and brainstorming sessions. Next, data were collected using an online questionnaire distributed to public transportation users in the Klang Valley. Then, the collected data were then analyzed using descriptive statistics, risk matrix analysis, and Poisson distribution analysis. Finally, the identified risks were prioritized and appropriate mitigation strategies were proposed to improve the effectiveness, reliability, and sustainability of public transportation systems in Klang Valley.
Risk identification was conducted to determine the main challenge affecting public transportation effectiveness in Klang Valley based on responses from 60 survey participants. 5 major risks were identified. R1, overcrowding and accessibility constraint with a mean score of 4.55. This represents the highest concern from respondents because overcrowding affects passenger comfort, accessibility, and safety, especially during peak hours. Fare increases and affordability pressure, R2, with a mean score of 3.92. The risk relates to the ability of commuters to continually use public transportation when fare becomes expensive. R3, traffic congestion and environmental efficiency, scoring 4.17 mean. Although public transportation reduces private vehicle usage, congestion can still affect travel efficiency and environmental performance. R4, which is frequent delays affecting commuters, scoring 4.47 delays. directly influence service reliability, passenger satisfaction, and schedule consistency. Finally, R5, which is service disruption and operational failure, scoring mean of 4.15, highlight problems such as interruption and system failure. These identified risks show that accessibility, affordability, environmental impact, and reliability are closely connected in determining public transport effectiveness. The risk metric assessment, where each identified risk was evaluated based on likelihood and impact. The assessment uses a 5-point scale. Likelihood measure how frequently a risk may occur, while impact measure the severity of consequences if the risk happen. The risk score is calculated using the formula risk score equals likelihood multiplied by impact. From the result, R1 receive a likelihood rating of 5 and impact rating of 4, producing a risk score of 20, classified as extreme. R2 receive a score of 16, which places it under high risk. R3 achieve a score mean of 9, classified as moderate risk. R4 frequent delays obtain a score of 20, also classified as extreme risk. The highest score was recorded by R5, service disruption and operational failure, with a score of 25. This indicates that operational problems are highly likely and create severe consequences for the transportation system. The risk metric helps decision makers prioritize which issue require immediate intervention. The 5x5 risk heat map, which is visually shows the relationship between likelihood and impact. The red zone represents extreme risk, where immediate action is required. 3 risks are located in the extreme category, which is R5, service disruption and operational failure with highest score of 25. This means failure in operation can significantly reduce reliability and commuter confidence. Second is R1, overcrowding and accessibility constraints, scoring 20. This reflects the pressure caused by high passenger demand, especially during peak periods. The third extreme risk is R4, frequent delays affecting commuters, also scoring 20. Delays create negative effect on travel time, productivity, and user satisfaction. R2 is categorized under high risk because increasing fare may reduce affordability and influence ridership. Meanwhile, R3 is moderate risk because although congestion affect efficiency, its impact is lower compared to operational issue. Overall, the heat map indicates that the priority should focus on reliability, capacity management, and also service continuity. The risk assessment chart compares the severity level of all identified risks based on their risk score. The highest risk is R5, service disruption and operational failure, score of 25, is critical because unexpected failure can stop service, increase waiting times, and reduce commuter trust. Second highest risks are R1 and R4, both scoring 20. R1 show that overcrowding remains a major challenge because insufficient capacity may affect accessibility and passenger experience. R4 indicate that frequent delays remain a serious concern because commuter depends on punctuality and predictable service. R2 recorded a score of 16, showing that affordability pressure is also important, especially for regular user who depends on public transportation daily. The lowest among the 5 risks mentioned is R3, traffic congestion and environmental efficiency, with a scoring of 9. Although it is not the highest priority, it should still be monitored closely because it will influence sustainability and travel efficiency. So the overall ranking shows that operational reliability is the most important factor to look up affecting transportation effectiveness. The Poisson distribution analysis, which evaluates the probability of delays experienced by commuters in public transportation. The average delay rate is represented by lambda with value of 2.72 delays per week. The result shows that the most commuters experience between 2 and 3 delays per week. The highest probability occurs at 2 delays with approximately 24.39%. As the number of delays increases, the probability gradually decreases. These findings support the earlier assessment, especially for R4, which identify frequent delays as a major risk affecting commuter satisfaction. The analysis shows that delays are not isolated incident, but a common experience among public transportation users. Therefore, improving punctuality, real-time monitoring, and schedule management are important strategy to reduce this issue, delay frequency. Overall, the Poisson analysis strengthened the evidence that service reliability is a critical component of effective public transportation system. The final stage is risk prioritization, where risks are arranged according to their urgency and required action. The highest priority is R5, service disruption and operational failure, with scoring of 25. The recommended action is to improve maintenance planning, strengthen operational monitoring, and prevent unexpected service disruption. Second priority, we look at R1, overcrowding and accessibility constraint. Improvement should focus on increasing service frequency, improving passenger capacity, and enhancing station facility. The third priority for the risk assessment is R4, frequent delays affecting commuters. Better punctuality management and real-time tracking system are needed to improve schedule reliability. R2, fare increases and affordability pressure require careful fare management and ensuring that subsidy reach the appropriate groups. Lastly, R3 focuses on environmental efficiency. Sustainable transport strategy are better and better integration between transport mode can reduce congestion and emission. So in conclusion, we agree that improving operational reliability should be the main focus because this risk directly affect accessibility, affordability, environmental performance, and commuter satisfaction.
Okay, this session will present the demographic profile of 16 respondents in this study. The respondents represent different gender, age, income, travel purposes, which providing a diverse perspective on the effectiveness of the public transportation in Klang Valley. So the findings show 81.7% respondents are working adult, aged 25 to 44 years old, while half of the respondents are female and working in the private sector. Regarding the travel behavior, most of the respondents use public transport for working, commuting every day, while LRT are the most common one, followed by the MRT. So overall, this finding indicate that public transportation play an important role in a daily commuting activity, particularly among working professionals in Klang Valley. The diverse respondent profile also strengthened the reliability and relevance of the study finding. Next, we will look at the finding of the survey. Looking at the key finding by dimension, respondents were generally satisfied with affordability and environmental impact. Both received a mean score above 4.0. This suggests that public transport is perceived as reasonably affordable and contribute positively to environmental sustainability. However, three major issues clearly emerge from the finding. The first is overcrowding, with the highest mean of 4.55. The second is service disruption, indicating that the respondent frequently experience operational and technical issues. And the third one is delay, with a mean of 4.47, showing that punctuality remains a concern among commuters. This finding suggests that while public transportation provides economic and environmental benefit, operational challenges continue to affect the overall user satisfaction. The issue of overcrowding, service disruption, and delay are closely related and may reinforce one another. Therefore, This area requires greater attention from the service provider to improve service effectiveness and commuter satisfaction. Okay, now this is where everything ties together. The survey result actually match with what we see in our risk matrix. The three extreme risks, R5, R4, and R1, has the highest score because they are closely connected to each other. For example, when there are operational failure, it leads to a delay. Those delays then cause passengers to build up at the station, which result in overcrowding. But it also works the other way around. When there is overcrowding, it puts pressure on the system, which will increase the chances of breakdown and will cause more delay. So it's not just a simple chain, it's actually a cycle. Because of this, we cannot just fix one issue and expect the issue to improve. We need to address all three together: reliability, capacity, and punctuality at the same time. That is the main finding from this part. On the next part, we will explain the mitigation process and how this risk can actually be managed and reduced.
Okay, next, I will present the proposed mitigation strategies. The strategies are prioritized according to the risk severity from extreme to the moderate. Since the risks are interconnected, the proposed strategies are designed to complement one another and improve the overall performance of the public transport system. Okay, next, R5 service disruption and operational failures. R5 is the highest priority with a risk score of 25. This reduces service disruption, preventive maintenance, real-time monitoring, backup systems, rapid response teams, and regular safety audits are recommended to improve service reliability and public confidence. R4 also falls under extreme risk with a score of 20. Since commuters experience an average of 2.72 delays per week, the proposed strategy includes improving schedule, increased service frequency, providing real-time passenger information, and monitoring punctuality using KPI. R1, overcrowding and accessibility. R1 is another extreme risk with a score of 20. The mitigation strategies include increasing train capacity, improving service frequency, managing passenger demands, enhancing station crowd management, expanding feeder service, and upgrading facilities for the elderly and also the disabled passengers. R2, fare increase. R2 is classified as a high risk with a score of 16. The proposed measures include maintaining targeted fare subsidies, introducing the integrated fare pass, improving operational efficiency, ensuring the transparent fare reviews, and diversifying revenue sources. R3, traffic congestion. R3 is a moderate risk with a score of 9. To address this issue, the strategy focuses on the encouraging public transport use, adopting low-carbon technologies, expanding park and ride facilities, and promoting the sustainable mobility through the transit-oriented development. In conclusion, the study identified R5, R4, and R1 as extreme risk, R2 as high risk, and R3 as a moderate risk. By implementing these mitigation strategies, public transport authorities can improve service reliability, commuter satisfaction, and build a more sustainable and resilient transport system. That's all from us. Thank you.